Dear viewers, today we will see type 2 error and power of the test. We will see first what is type 1 error. We will visualize this. It is rejecting the null hypothesis when it is true. In this, you are seeing two normal distribution curve. One is assuming that null hypothesis is true. And we have taken a significance level of 5%. And then what we do is, for this 5% significance level, from the standard normal distribution curve, we are finding out the critical z value. We are converting this critical z value into critical variable value. Then what do we do? If the value is below this critical variable value, then we are rejecting this null hypothesis. Even though it is falling under null hypothesis, we are rejecting it. Therefore, this is called type 1 error. The significance level, we are fixing it beforehand. So that itself is the type 1 error. Now, what is type 2 error? Not rejecting the null hypothesis when it is false. Please note, what we are doing is when the variable value is above this critical value and falling in this region to the right of this critical line, we are saying that null hypothesis is correct, right? We are not rejecting null hypothesis. Understand? But if this happens to be false, then we should not take this curve. Then what is the correct curve? This red curve is the correct curve because mean is here, the alternate mean we have taken. And in this area, we are accepting, we are not rejecting the null hypothesis when it is false. Because this is under this curve, this is to be rejected because this is false. But we are saying that we are not rejecting the null hypothesis. Therefore, this is called an error and type 2 error. Right? And this area, to the left of this, we are rejecting anyway the null hypothesis, and it is true that it is to be rejected because it is under the alternate hypothesis mean. Therefore, this is called power. We can find out the power either by calculating this area or subtracting this type 2 error from 1. Okay. Power is the probability of rejecting the null hypothesis when it is false. That is what we have seen here. When this is false, this is the curve and this is the area we are rejecting. The probability of this area is nothing but the power. Okay. Now, power and type 2 error depends upon the mean, population mean, alternate population mean, as well as null hypothesis population mean, sigma standard deviation, sample size n, and significance level alpha. Now we will take a problem. There is a normally distributed population. Population mean is unknown. There are two statements. Null hypothesis says one, alternate hypothesis say another. The population standard deviation is known, 20. We will take randomly 30 values. That is sample size is 30. We are going to test the hypothesis at 5% significance level. Null hypothesis and alternate hypothesis are there. We are going to see for what values of sample mean, we will reject the null hypothesis. And for what values of sample mean, we are going to accept the null hypothesis, fail to reject the null hypothesis, right? So for that, what we do is we have to convert this 5% significance level to critical z value from the standard normal distribution curve, right? So it is minus 1.64 from standard normal distribution. And substituting this value here, we will get the critical mean value, which is 54.01. You can do these calculations leisurely. We will reject the null hypothesis if z value is less than or equal to minus 1.64. That means we will reject the null hypothesis if sample mean is less than or equal to 54.01 because this sample mean is corresponding to this minus 1.64. Clear? Now what we will see here is the probability of rejecting the null hypothesis when this mean is correct. That is called power. The probability of not rejecting when this mean is correct. That is, this area is type 2 error, this area is power. Okay. We'll take this problem further. Now, critical value we have found out to be 54.01 for a 5% significance level. Suppose the claim is that mean is not 60 but 50, then we'll have to find the type 2 error. Type 2 error is not rejecting the null when the null is false. That is, do not reject the null when mu is equal to 50, not 60, right? So this is type 2 error. This curve we are going to take, right? And then this is the area for type 2 error. Okay. We know we reject null hypothesis if x bar is less than or equal to 54.01. right? This one, this area, right? So type 2 error is x probability of x bar greater than 54.01, greater than 54.01 when this mu is correct. The alternate mu is correct. This is the area. This is called type 2 error. So tell me which normal distribution we should use. Red line. Obviously, the normal distribution with alternate mean. So z value we will recalculate. So we will have to use the same critical value 54.01, but mean I have to use the new mean value. Then z value becomes 1.099. Then probability of z value greater than 1.099 is what is this area, which is 0.136, which is what is type 2 error. Right? Power we can calculate either probability of z value less than or equal to 1.099, that is this area, or simply 1 minus 0.136, 0.864. In both the cases, we will get the same value. Right? We can also find out using this Excel solution. We'll go to this Excel. Right? We will see this. See here, we will take the 60 is a problem, and then this is at 0.05. We took this as 20, and then we took this as 30, and then we took this as alternate mean as 50. So you are getting 0.136. Yeah. So we can also change this to 0.09, and then you will see this 0.081. Right? So it decreases. Right? It decreases. It is now 0.081. When I decrease alpha, this will increase. When I increase alpha, this will decrease. Clear? 0.05, 0.136. 0.5, you will get 0.136. It increases. Okay? And then we will also try to do one more problem here. That is what we will see here. 50, and then we will take this as 21, and then we will take this as 36, and then this will take it as 40. We will see this result. This is 0.112, and if I take it as 0.09, it will decrease. I'll take it as 0.09. From 0.112, it will decrease 0.065. Right? And then we will also try to do all these values. We will see it in the PowerPoint. And we will also take this two-tailed test. Two-tailed test is the area to the left of this as well as to the right of this critical values. Because you have two tails, you will have two critical values for the null hypothesis statement as well as for the alternate hypothesis statement. So we will take this one problem, 75 and 0.05. Sigma value is 8, sample size is 16, and mu is 77. That is, alternate mu is not 75, but it is 77. So we will find this. Type 2 error is 0.829. Power is 0.171. Right? So what I will do is I'll make it as 0.09. Right? From 0.829, it decreases to 0.075. Okay. This is what I just wanted to show you. And then we'll go back to this thing. And these are all the values we have seen. Just by substituting the values in the Excel table, we will get all these answers. Right? Now, this is for a two-tailed test. For two-tailed test, this null hypothesis true means this. You will have this area to the left and then one value here to the area to the right. But then when this is false, I'm taking this normal distribution curve and recalculating this critical values lower and upper and finding out the area to the extreme, and that is called type 2 error. And what is power? Power is the in-between area. This is the power because this is to be rejected and we have rejected. Right? This also is to be rejected, but we have not rejected because we have accepted the null hypothesis. I think I'll stop share. If you like this video, please share it with your friends. Thank you very much.